now let's talk a bit about the main topics of the lecture we're actually going to look at. So today I want to talk a bit about what mobile devices actually are, how can they be classified, what is common hardware and software we're going to deal with, and what are the most important features and also issues we have to deal with when we use mobile devices and also when we develop for mobile devices. All right, so the easiest way to actually classify mobile devices is by just looking at the size. So at the high end or at the large end of the spectrum, so to say, we have something like a regular laptop, which is let's say 17 or even maybe 19-inch display and can be pretty large. It has more or less the same power as a desktop computer, so you can have a dedicated GPU, you can have a big battery, you can extend it with USB and other plug-in cards and so on. So this is relatively close to a desktop computer, but it's also quite large. One step smaller, we have what we all carry around in our pockets, like mobile phones, tablets, and so on. They're smaller, of course, but also have reduced capacity. And to make up for that reduced capacity, we often use something like cloud synchronization or synchronization with our local machine to make up for that limited storage capacity, for example. Then something that's usually, if we're just looking at size, which is usually in the same ballpark as a tablet or a mobile phone, is a so-called onboard computer. This would be something like the engine control unit in a car. So this is still a computer in a more general sense, and it's also a mobile computer, but it's one that's purpose-built for one specific task. For example, like controlling the timing of the valves in a combustion engine or so on. And especially, usually this is also something used for time-critical tasks that have to be completed within one specific millisecond or so. Other example would be a quadcopter or a drone, because there you also need to adjust the motor power, for example, within milliseconds so that it doesn't just tilt over and crash. If we're looking at even smaller devices, then we're getting into the area of wearables, for example, something like a smartwatch, or there's also smart badges or something like that that you can wear on your clothing. What they have in common is because of the size, they only have very limited screen space, and so it's also quite hard to do manual interaction with those devices. I remember that I had a very early smartwatch from Sony, which had maybe something like a 1-inch screen, and which required you to do pinch zoom on that screen to do certain actions, which really did not work very well. So in most cases, you would just have to rely on swipe gestures or something like that to interact with these devices. If we're getting even smaller, then we're looking at something like a chip card or a SIM card, like the card in your bank card, for example, or the SIM card in your mobile phone. All of these are still computers, programmable computers, which are of course very small and therefore have very limited capacity. Maybe it's something like, I don't know, 64 kilobytes of storage or so, but they still have a dedicated processor in there that's, for example, doing cryptography stuff to secure the communication between your mobile device and the cell tower, or between your bank card and the reader in the store. All these kinds of things are also handled by these very small, dedicated mobile systems in the widest sense. And in a similar category, also in a similar size category, we then have NFC tags, which are quite similar to chip cards or SIM cards, for example. You can even have contactless chip cards, which are more or less a hybrid between NFC tags and chip cards, which don't use these contacts anymore to communicate between the card and the device, but have a contactless short-range wireless communication standard. So of course it's a very simplistic classification to just look at the size, and people have been trying out all sorts of new form factors. So, for example, since a few years we have these convertibles, for example, which are tablets that have a rather big and beefy CPU and some sort of keyboard that you can attach magnetically, or maybe that you can fold to the back or so. So it's somewhere in between a tablet and a laptop computer, both in terms of size and functionality, and also in terms of capacity. Then a few years ago from Google, we had this quite interesting project ARA, which is just a spine basically for the smartphone, and you could attach all sorts of modules to that. And the idea was that you could actually swap out individual parts of your smartphone to upgrade them without having to like buy a new screen if you're still happy with the old one. If you just want a new camera, then you just buy a new camera module. But of course, it was quite difficult to get all these different connections to work, and also to have the whole thing stick together well enough. So that was abandoned at some point, but it's still a very interesting project. And more recently, we're seeing lots of dual display devices. So one is phones that have displays on both sides, maybe an e-ink display on one side and a regular color display on the other side. Or we're seeing these folding phones like that new Motorola Razr or the Galaxy Fold that you probably heard about, because it kept getting cracked and so on when you fold the screen because there was dust underneath and so on. So that was actually something quite difficult to get right, but it's still something people are experimenting with to, for example, have more screen space in a smaller device. All right, so as I already mentioned, size is a very, very generic classification. We can also look at the purpose. Most of the devices I just mentioned are general purpose devices, so you can have different sorts of applications on there. They have a flexible operating system, which has interface definition for those apps to use and so on. And on the other hand, we have special purpose devices like the flight controller, for example, for a quadcopter, or the engine control, which is still a computer, but one that's programmed for one specific task, and where you can't just like install a different app or so. Often because it's really time critical what these devices need to perform, because you need to have a guaranteed reaction time of something below 1 millisecond or so, and that's usually not something you can achieve with a general purpose device, because you all have all sorts of different apps and so on running in the background that just happen to take more processing time than your important task would actually need. So for these reasons, if you need time critical control tasks in whatever mobile system, then usually you have this sort of special purpose device dedicated to one task, as opposed to a general purpose device that you can still use for control, for example. All right, so here's again an overview over the different types of devices and size classes. So here we have the general purpose devices, and here we have the special purpose devices. For the scope of this lecture will going to focus mostly on general purpose devices here in that area of handheld and wearable. A few examples for special purpose devices that still exist but are often kind of getting subsumed by smartphones. You have stuff like a dedicated ebook reader, or maybe a navigation device in the car. That's kind of a mobile special purpose device, and a lot of these have been subsumed by smartphones by now. So we're going to focus on this part of the spectrum, on general purpose handheld and mobile devices and wearables. Of course, there's also quite a big area of special purpose wearables, for example, like medical measurement devices, or just a plain old watch is also like a special purpose wearable, for example, but that's not going to be our main focus. So, all right, to summarize, we have like two major dimensions we're going to use for classifying mobile devices, the size and the purpose. For the size, we have a very large range, somewhere between 1 millimeter for the chip in a SIM card and probably 50 centimeters for a high-end laptop with big screen and so on. And we have the other dimension of looking into whether it's a general or a special purpose device. And of course, there's also a bit of overlap here. It's not quite binary. All right. So